For today's video, we are going to discuss improper integral with discontinuous integrand. So we have here an example of improper integral, which is the integral of from 0 to 4 with the expression of 1 over cube root of 4x dx. So we can rewrite this function as this one as 4x minus third raised to negative 1 third, since these two are the same. After we rewrite this expression, we can write the limit as b approaches to 4 from negative side, integrating 0 from 0 to b. Since we are evaluating 4, we can use this b as the representation. Then write this function 4 minus x raised to negative 1 third dx. Then we can find the derivative, or different. We can differentiate this 4 minus x raised to 1 third as using the power rule. um, 1 minus negative 1 over third minus 1 is same as 2 third, but we can rewrite, can put down here as the reciprocal of the sum of the 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 power. So we can write as negative 2 third as divided by 4 minus x 2 third raised to 2 third, evaluated from 0 to b. Then the next is so this part here, we can simply write the using the fundamental calculus, or using the how to evaluate this function. So all we need to do is plug in this 0 and b value into our expression, find the difference of these two. So as you can see, if we plug b in here, we can get that 0. So 0 will raise to. So notice here, in negative 2 third, 2 over 3 over 2 divided by 4 minus b. We plug 4 here, we can cancel out this expression. So we only need to do is we can focus um this one here, this thing here. So we can write 0 correspond to this, and this one, if we multiply negative times negative, we could get a positive, and copy 3 over halves, 3 over 3 over 2 divided by 4 minus 0 is 0 raised to 2 over third, or simply we can write this as 3 over 2 times 16 over 1 third, since if we use or evaluate this one, we can write this as uh, we could write this as 16 over third, and 16 over third is the same as 8 raised to 1 third multiplied by 2 over 1 third, and um, 8 over third is the same as 8 over 1 third is the same as the cube root of 8, and the cube root of 8 is 2. And 2, if we multiply the 2 here, this is 2. If we multiply 2 times 3, it's 6 divided by 2, so we could get 3. We could get 3 and multiply what's left, 2 over third. So the final answer is 3 times 2 over 3 times 2 raised to the power of 1 over third. Since it is a finite number, so the the function or the integral is convergent. We have here another example of improper integral, discontinuous integrand. So if we evaluate this function as x is equal to 2, so we could say that x is equal to 2, this function is indeterminate. So we could rewrite this as, we could um, rewrite as the integral from 0 to 2 x over x squared, x over x minus 2 dx, plus the integral of 2 from 2 to 5 x over x minus dx. So all we need to do is we can evaluate uh, one of these two functions, because if we find this first function as divergent, all of uh, both of them will be divergent. So it's rewrite as the limit b approaches to negative 2, since we are now evaluating the 2, because if we substitute 2 into x, it is indeterminate form. So we could say that uh, limit from the limit approaches b, from b approaches to 2 to negative of the integral of 0 to b x over dx is, we can use the u substitution. So our u here is x minus 2. We can find the derivative of u. Derivative of u is du, and derivative of x minus 2 is dx. And so, and we can say that x is equal to u plus 2 if we uh, find the x value here. So now all we need to do is plug in, substitute x. Our x is u plus 2. Substitute x minus 2 is u. Substitute u, and du is simply plug in dx. So u divided by u is 1. We can write this as u divided by u is 1 plus 2u. Find the antiderivative of this. So the antiderivative of 1, antiderivative of 1 is u. The antiderivative of 2 over u is 2 ln the absolute value of u plus c. Also, we can now substitute the u value here. So u is equal to 2x minus 2, and 2 ln u of the absolute value of u is uh, the absolute value of u is x minus 2 plus c. But anyways, you can disregard the c here later on. So the next step is we can now evaluate the limit from b approaches to 2 as x minus 2. Now we can now evaluate this x minus 2 plus ln the absolute value of x minus 2 evaluated from 0 to b. So the next part is to evaluate with the fundamental theorem of calculus. So we could say that if we plug in the b value here, value here of x, b minus 2 plus the ln value of x, so b minus 2, and so evaluated, we can now evaluate the lower limit also. So x is just substitute 0, x is substitute 0, x 0 minus 2 plus the ln x substitute 0, 0 minus 2. So we can now evaluate as, so in this part here, so we can now substitute 2 of our b. So we can evaluate now, substitute 2 minus 2 is 0. So simply the ln b minus 2. So we are now be careful this part here, as so we need to be careful here. So because if we substitute of b minus 2 as b approaches to 2 is equal to is this number here will be approaches to 0, since which get graph here as the lnx graph here. So notice that if we substitute 2 in the b, we could say that the value of this absolute value here is approaches to 0, since we are now approaches from right to left. So, so it would be like it would be the negative, but we are now approaches to from right to left. So the value of this ln b minus 2 is negative negative infinity. So in this part here, next is all we need to do is copy the 0 minus 2 plus the ln of 0 minus 2 is ln 2. So notice that if we add and find the sum of this and the difference, or the sum or the difference of this, we could say that it is um, the answer will be negative infinity. And so that it is the number is in a infinity form. So it diverges. This function is divergent.